Okay, hi everyone. One second. This is Unit 5, Y's exponents. I don't know why it's not loading though. It should. There. Okay. It's 8 lessons. Okay. This is Unit overview. Vocab box. Okay, the base is the number being multiplied. Power, an expression written with the base and exponent. Integer, a positive whole number, negative whole number, or zero. Absolute value, distance from zero. Product, answer to multiplication. Estimate, a reasonable approximate answer. An exponent, how many times the base is used as the factor. Perfect square, a number equal to n times n. Opposites, number the same distance from 0 on opposite sides. Zero pair, one positive and one negative counter. The quotient, answer to division. Number line, model showing numbers in order. Okay, this is lesson 1, patterns with whole number exponents, brief explanation model. So an exponent tells how many times the base is used as the factor. For example, 2 root 5 is 2 times 2 times 2 times 2 times 2. Look for patterns as exponents increase. Multiply one or more copy of the base creates the next power. Remember, base equals repeated factor, exponent equals number of factors. That's an example. 3 fourths. That's the practice. Explain how you know. That's the homework. Number 1, write 7 root 2, no, 7 squared as repeated multiplication and evaluate. Number 2, write 6 times 6 times 6 using an exponent. Number 3, evaluate 2 to the 7th power. Number 4, complete the pattern. 5 to the first equals 5, 5 to the second equals 25, 5 to the third equals, yeah. These are the answers. Number 1 is 49, 2 6 cubed. Number 3 is 128. Number 4 is 125. Okay, this is a brief explanation. Okay, perfect square is a product of a whole number multiplied by itself. Square arrays have the same number of rows and columns. Examples: 1, 4, 9, 16, 25, 40 are perfect squares. Remember, n squared means n times n. 20 squared is equal to 400. Perfect square makes a square array. 4 times 4 is 16. 4 squared. Okay, let's do practice. And this is the homework. Okay, number 1, draw and describe a model for 6 squared. 2, find 12 squared. Number 3, what is a perfect square? 1 to 20, 1 to 21, or 1 to 22. Number 4, complete 18 squared equal to dash and 20 squared equal to dash. Number 1, answer 6 times 6 squared array, 36 tiles. Number 2, 144. Number 3, 121. 11 squared. Number 4, 324 and 400. Okay, lesson 3, is it a perfect square? To decide whether a number is a perfect square, ask whether one whole number is multiplied by itself gives that number. You can use a square model or list of square numbers or nearby squares to justify the answer. Remember, between consecutive squares, know what the perfect squares occur. Is 144 a perfect square? 12 times 4? No, 12 times 12, 144. 12 by 12 squared. Yes, 144 is 12 squared. Roll. Let's practice. This is the homework. Okay, number 1 is 169 a perfect square. Explain. Number 2 is 180 a perfect square. Use nearby squares. Number 3 is 324 a perfect square. Give the square root. Number 4 is 399 a perfect square. Explain. The answers. Number 1 is yes. 13 squared is 169. Number 2, 13 squared. No, it's no. 13 squared equals 169. 14 squared equals 196. Number 3, yes. 18 squared is equal to 324. The square root is 18. Number 4, 19 squared is 361. And 20 squared is 400. Lesson 4, powers of 10 and base value. Powers of 10 show repeated multiplication by 10. 10 to the power of 1 equals 10. 10 to the power of 2 equals 100. 10 to the power of 3 equals 1000. For positive whole number exponents, the exponent tells how many zeros follow the 1. Remember, multiply by 10 shifts digits 1 place left. 10 to root 0 is 1. 10 to 1 is 10. 10 squared is 100. 10 cubed is 1000. 10 to the 4th power is 10,000. Each increase in exponent multiplies by 10. Also, remember, multiply by 10 shifts digits 1%. That's the practice. Okay, and that's the homework. Wait, is this the same? No, it's not. Okay. Write 10 to the 6th power in standard form. Write 1 million as a power of 10. Number 3, what is 9 times 10 to the power of 4? Number 4, find 328 times 10 cubed. Okay, number 1 is a million. Number 2 is 10 to the power of 6. Number 3 is 90,000. Number 4 is 328,000. Lesson 5, integer operations with visual models. Brief explanation of model. Integers can be modeled with positive, negative counters, and number lines. A positive and a negative counter makes a zero pair. For multiplication and division, repeated groups and sign patterns help show why the sign of the answer changes. Remember, zero pairs have a total value of 0. Okay, let's practice. It's the homework. Number 1, model -5 plus 2 with counters. Number 2, use a number line to show -2, -5. Number 3, model -4 times 2 using groups or a sign pattern. Number 4, use a model or reasoning to find -15 divided by 3. Number 1 is -3. Number 2 is -7. Number 3 is -8. Number 4 is -5. Lesson 6, add, subtract, multiply, and divide integers. Brief explanation model. Use integers rules to compute efficiently. For addition, compare signs and absolute values. For subtraction, add the opposite. For multiplication and division, same signs give a positive result. Different signs give a negative result. Okay, remember subtracting an integer adds its opposite. Add same signs, add, keep the sign, adding different signs, subtract, keep the sign of large absolute value, multiply, divide, same signs plus different signs. Example, -6 times 4 equals -24. Let's practice. Explain how you know. Okay, and this is the homework. Number 1, find -15 plus 9. Number 2, find -4 minus 11. Number 3, find minus 9, -9 times 6. Number 4, -72 divided by -8. So, yeah, okay. There's the homework answers. Number 1 is a -6. Number 2 is a -15. Number 3 is -54. Number 4 is 9. So lesson 7, absolute value and integer expressions. Brief explanation and model. Absolute value tells a number's distance from 0. First, simplify inside absolute value bars. Then perform the integer operation. Finally, locate the result on a number line to check its sign and size. Remember, negative a in the absolute value is because it is equals a because the distance is non-negative. This is an example. Let's practice. Explain how I know. Okay, this is the homework. Simplify -12 in that absolute value, like that with brackets, and then plus -7. Simplify 4 minus 10 in those absolute values things, and -1. Number 3, -5 in those absolute value things, plus 9. Number 4, -3 in those absolute value things, times 4, and state where the result lies. Number 1 is 5, number 2 is 5, number 3 is 14, number 4 is 12. 12 units to the right of 0. Lesson 8, integer problem solving, brief explanation model. Integer problems often describe changes in temperature, elevation, money, or scores. Identify the starting value and each change. Estimate first, write an integer expression, solve, and explain what the integer means in context. Remember, a reasonable estimate helps catch sign numbers. This is an example. and then check sign on whether the answer is reasonable. Let's practice. Explain how I know. And this is the homework. Okay, number 1, the temperature is 4 degrees Celsius and falls 13 degrees Celsius. What is the new temperature? Number 2, an elevator starts at floor -2 and rises to 9 floors. Then it drops 4 floors. Where does it stop? Number 3, a team gains 6 yards, loses 11, and then gains 8. What is the net charge? Number 4, estimate and solve. A hiker is at 120 meters, descends 85 meters, then climbs 30 meters. Number 1 is -9 degrees Celsius. Number 2 is floor 3. Number 3 is plus 3 yards. Number 4, estimate about 70 meters, exact 65 meters. This is the unit review. Use one strategy from each part of the unit. So solve each problem. These are the answers. Number 1 is 243. Number 2 is yes, 17 squared is 289. Number 3 is 10,000, 6,000. Number 4 is -7, -8, 24, -9. 5 is -3. Number 6 is 2 degrees Celsius. And this is the performance task, unit reflection. Okay, thank you guys. If you guys have any questions, please ask. Sorry if this like a bit